All right, so our next lesson is on page 4 of our unit packet. And in this lesson, we're going to learn how to balance chemical equations so that we can follow the law of conservation of mass. All right, so we've learned how to write chemical formulas using our formula writing rules. Another thing we have to look out for when we write chemical equations, there's something called diatomic elements. These are elements that are found in nature as two atoms bonded together. So there are 7 of them that you need to know. Those 7 are, and I use an acronym, it's called Brinkelhoff. So the way we write the Brinkelhoffs is bromine, Br, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Okay? So if you run into any of these 7, you're going to write their formulas, and this is in their elemental state, not part of a compound, as like Br2, I2, N2, Cl2, H2, O2, F2. So this is when they're in their elemental state. So if I had like nitrogen as part of a compound, maybe like calcium nitride, I would use my correct formula writing rules where I would write calcium and nitrogen, and then I would crisscross their charges. So I get Ca3N2. This 2 is here only because calcium has a +2 charge, and we had to crisscross our charges. It is not here because of this, because of the Brinkelhoff. So when you have nitrogen by itself, it would be N2. When nitrogen's part of a compound, so if I had like aluminum nitride, the formula would just be Aln, +3 and -3. So there's no 2 on the N when it's part of that compound. So it's important to remember that these 2's are only on as a subscript on these elements when they are in their elemental form, so they are by themselves, not part of a compound. So steps for writing for balancing equations. First, you're going to write the chemical equations, writing the correct formulas for the reactants and the products. You want to check for your diatomic elements, which I use the Brinkelhoff. I'll show you the 7-up rule in class when we have a periodic table out. And then sulfur is called, we use the formula S8. So there's 8 atoms of sulfur when it's in its elemental state. So kind of the long way of doing is listing the number and type of each atom and then adding coefficients to balance the equation and according to the law of conservation of mass. Now, once you write the formulas, you cannot change the subscripts. You can only add coefficients. So some of you may have done balancing equations before, and you would have been given this reaction, and then you would have had like a little table underneath where you would list each of the reactants, the elements, and then the elements that are part of the products. And that's one thing that's important to notice is, have you written formulas where maybe your formula is incorrect and you have different elements on the left side and the right side, where you can't make a new element or lose an element in the process of a reaction, a typical chemical reaction. That happens in nuclear reactions, not in your typical chemical reaction. So make sure you have the same elements on both sides, so that's good. And then you can look here and see you have 2 atoms of hydrogen and 2 atoms of chlorine. And over here, we have 1 and 1. So I would need to multiply both of these by 2 so that we get 2 atoms of hydrogen and 2 atoms of chlorine, which means I'm going to put a 2 coefficient out in front of the hydrochloric acid. Okay, so this big 2 out in front is a coefficient, and it applies to both the hydrogens, and I have 2 hydrogens, and it applies to the chlorine. So you multiply coefficient times subscripts to get the total number. Now, in reality, we really don't have time for you to set up a little table and to list all of the elements and to do all that. We need to be able to balance equations by sight. So to do this by sight, I would go through and see, I would look at iron, I'm good, there's 1 on each, and then I get here to the bromine, I've got 3. So I would come over here and put a 3 in front of the sodium bromide. I can't add a 3 subscript on bromine. That would be changing the formula. So I'll add a 3 here. Since that also changes to 3 in sodiums, I'm going to come back over here in front of sodium and put a 3. And now I have 3 chlorines, which balances the chlorines on the right side. So we're balancing by site, meaning you're going back and forth between your left side and your right side and checking that you have the same number of each element on both sides. Okay, so let's go down here to the third example. When you balance by site, it's much easier to first look for polyatomic ions. So you'll see up here in the notes some helpful hints. If they're not already there, put parentheses around your polyatomic ions and treat as one unit. So if you have the same polyatomic ions on both the left side and the right side, just count them as one thing, okay? And balance polyatomic ions first. So I can see in example 3, I have hydroxide here on the left and hydroxide on the right. So I'm going to go ahead and take care of that first. So I have a 2 here and a 3 here. And an easy way to fix that is to kind of do the opposite. So I'm going to have a total of 6 hydroxides on both sides. So I'm going to do a 3 here and a 2 here. So now I have 6 hydroxides on both sides. Then I can balance my individual elements. So now I can put a 3 here for copper and a 2 here for aluminum. Okay. So let's go down here to example 4. Okay, so this is a good example of one where I have a polyatomic ion, but you'll notice that it breaks down. So I need to count it separately. So one thing I look for are these 3s and 2s. Okay, so I've got 3 oxygens here, 2 here. So I'm going to just multiply by the opposite. I'm going to multiply by a 2 here and a 3 here. And now I have 2 cesiums and 2 chlorines. So I'm going to put a 2 right here. And that one is done. Okay. In our next example for number 5, this is an example of a combustion reaction. So we're not learning types of reactions yet, but this is one that's really easy to pick out. And if you identify these types of reactions, there is kind of a sequence of elements, kind of an order that you want to balance these in that makes it much easier to balance. Right, so I know this is a combustion reaction because I have something here called a hydrocarbon, meaning there's carbon and hydrogen. It's reacting with oxygen gas, and the products are always CO2 and water. So if I run into a problem where I have a hydrocarbon reacting with oxygen to make CO2 and water, I'm going to say, oh, that's a combustion reaction. So then my order that I want to use is to balance my carbons first. Then you're going to balance hydrogen. Then you're going to balance the oxygens. Okay, so you're going to do carbon, hydrogen, oxygen, and then check. You're going to double everything if needed. All right, so CHO, then double if needed. So let's see how that works out for this one. I'm going to start with carbon. There are 3 carbons on the left side. So I'm going to put 3 here in front of CO2. There are 8 oxygens on the left side, so I'll put a 4 here. Now add up all of your oxygens. So 3 times 2 is 6. And then there's another 4 times 1 is 4. So I have a total of 10 oxygens on the right side, which means I need to put a 5 in front of O2 here. Okay. So you're going to do CHO and then double if needed, right? So we're actually going to hold off on doing particle diagrams right now, but let's go ahead to page 5. This is going to be your practice with this assignment. I'm going to work through a couple of problems to help you get started, and then you'll be on your own after that. So number 1 is a great example of where we have actually 2 polyatomic ions that we can get balanced first. So the first one I'm going to look at is I've got silicate and I also have nitrate. This nitrate, I see 2 here and 3 here. So that's an easy one to start with. I can put a 3 here and a 2 here. And then I see 3 silicates here, and there's only 1 here. If you wanted to, you could put it in parentheses like that. Okay, so I'll go ahead and put a 3 here, and you'll notice that my individual elements, the technetium, so 2 and 2, and the cobalt's 3 and 3. So it's done. All right, let's try number 2, and then we'll find us a combustion reaction to try together. So I've got, first of all, I could put my polyatomic ion in parentheses because I see it on both the left and the right side. So if there's 2 of them on the right, I can go ahead and put a 2 here. Now that changes my number of silvers. So I'll put a 2 here. And that actually fixes my chlorine problem because I had 2 on the left side and now I have 2 on the right side. So that one is done. Okay. Let's skip down here to number 4. Number 4 is a great example of a combustion reaction. And how do I know that? It's got a hydrocarbon reacting with oxygen to make CO2 and water. Okay? So this is the one you use CHO and then double if needed. So if you have like an odd number of oxygens on the right on one side and an even number on the other, you might have to double. So I'm going to start with my carbons. I have 10 here, so I'm going to put 10 here. 22 hydrogens, so I need 11 right here in front of water. So don't be afraid of the big numbers, just let the process work itself out. So I've got 20 oxygens here, plus 11 gives me 31 oxygens. So to get 31 oxygens on the left side, I would need 15 and a half O2s, which is not a real number. You can't have a half of an O2. So now I know that I need to double because I am ending up with a half of one. So I'm going to put a 2 here, make this 31, make this 20, make this 22. Now everyone is happy. Okay, it is balanced. So you can finish page 5 on your own today, and then tomorrow's lesson is going to be page 6.